Hello, I'm Tom Hollingsworth, and this is Networking Field Day 13. We are here in sunny Silicon Valley, California, with SolarWinds. You are about to watch a presentation featuring SolarWinds and their unique solutions and products, along with a group of delegates around the table who represent the best and brightest in the networking industry. They have been invited to ask questions, make comments, and offer their opinion, and represent the networking community at large. If you would like to know more about Tech Field Day, including how to become a delegate or how to become a sponsor of this event, please go to our website at techfieldday.com. If you would like to see more videos like this about a wide range of technology subjects, please check out our YouTube channel at youtube.com/techfieldday.
We'll take a look at, give you an update on our progress. So now that you remember what it is, you may notice there's a bunch of labels, so I can now tell what the heck I'm demoing, and there's a lot of other changes. There's a lot of data integration. We're going to go into how it works, which sounds like maybe one of the most interesting parts for you guys. I presented this in February 5th, as I mentioned. We shipped it as a feature on June 7th. Okay, so it took us like 4 months there. We did not know if we were ever going to get it good enough to ship it as a feature when I presented it to you guys. I think the chances were like 50-50, so that was great that we actually were able to ship it as a feature on June 7th. Now, since then, it's been, what, 5 months or so? We have had some crazy adoption. So we now monitor over 9,000 unique services on the internet or locally in people's networks. We have 50,000 unique source destination pairs. So we've talked about how there's lots of multipath on the internet. When you have a source and you have a destination and 100 paths in between, we're counting that as one unique source destination pair. Okay, 140,000 endpoints, 120,000 networks, and 350 ports we're seeing. So one of the cool things I like to remember about the networks is networks are autonomous systems that we've identified. So this is the, not unique necessarily, but the times we're seeing the networks in a specific path. So we get sort of that perspective on that network, is that specific paths through that network. 120,000, when we originally developed the internet, the AS number was 16-bit, right? So 65,536 options here, and we're seeing 120,000 networks today. So obviously they've expanded now they have 32-bit ASN and all that sort of stuff, but really cool for sort of a feeling of scale of how much visibility we're starting to get, how much deployment we're starting to get. 350 ports, which I mentioned, one of the things I was really worried about when we first deployed this is people will think this is only for websites, and it's not. In fact, there's little to no technology that's really specific to HTTP, HTTPS. You can use it for your CIFS file transfers, you can use it for Exchange, you can use it for whatever you want in this TCP. So I'm really excited to see this 350 ports. If you break that down, it's predominantly web ports, right? There's 443 taking up 38%, also another like hooray. Encryption is getting more popular than port 80, sitting at 26% of all ports we monitor. 13% is 22, which is basically people trying to cheat, and they don't like me saying, go and monitor your application. They're like, I'll just make it a router, and my router has SSH. And then other. And this other is 23%. So 23% are 36% is stuff other than web browsing. Right? And that's comprised of all of these ports over here. And this is a ridiculous graph, intentionally ridiculous, because it's showing that we have a lot of 22, a lot of 23, and then we just get into this long tail of all of these different ports we monitor. So again, I'm really excited about that. It shouldn't just be websites only. And the user base is clearly understanding that and monitoring all sorts of cool stuff.
Brian, I may have missed this, but when you're doing these probes, are you also looking at like the path MTU as part of the discovery?
We don't touch MTU, no.
You're not probing to see
we are not.
how big of a packet you can get through the links?
Some of the lessons that we've learned, one of the things we were most concerned about when we were building this in the lab was security alarms. And that came up in the last presentation I did. You guys were like, hey, totally cool. Now you're just throwing a ton of network traffic that's probing, and this could look like a denial of service. It could be bad for my firewalls. It could be all sorts of stuff. And And yeah, it could. I was quite nervous about that. So we are careful with how much we send. We are careful with how we construct the packets to minimize application problems that could be created, all of this sort of stuff. And happily, after doing alpha, beta, release candidate, and now in production, a large number of environments, we've seen very few security issues. The most common security issue we see is that we produce more log messages. We've heard that reported a couple of times. And we definitely have challenges sometimes with getting through firewalls. And we'll talk about some of our technology around that. We can generally get through firewalls, but no one ever sort of impersonates the application perfectly. So there's always that potential that you'll be blocked. NAT is really dirty. I love NAT for its simplicity. As we've sort of deployed this to a larger audience and we've troubleshot and done lots of packet captures with all sorts of firewalls and routers and devices doing natting, we found not only does NAT do natting by itself, and you have NAT exclusions and some things that bring some complexity to it, but there's also some unexpected stuff. Like, you know that sometimes it's natting your payload as well, so you get a consistent behavior for the application. Sometimes it's also natting, particularly on firewalls, they consider their job security. Their job is security, right? But they will also, when you place a NAT boundary, they will NAT not only what you configured, but intermediary nodes past that as well, because they're trying to obscure that from the lower security zone. So then we get into real difficulty in figuring out what the heck's going on here. NAT's pretty dirty. Spoofing is everywhere. I did not realize it. I don't know if you guys realize it. Maybe everyone knew this but me, but spoofing is all over. Web proxies and WAN optimizers and all of these different devices not only are in the transit path, but they pretend to be your destination. Right? And then when we do a Netpath, we will see that true destination, but that's not what the user expected. Right? They didn't expect to see their proxy as google.com, but it is google.com technically. So that's been an interesting lesson for us. We also learned very quickly that customers notice even small latency inaccuracies. We had a bug in the product where we would misattribute 10 milliseconds, about 10 milliseconds of latency to the wrong link in certain scenarios. And we found that out like within 5 days, and we had to get a hot fix out. People notice when we put the wrong numbers up on the screen. It's very cool. It helps to have a LAN on your team. So our lead developer did not only the probing algorithm development, a big chunk of that. We had a couple of people, but he did the main chunk of that. But he also did sort of the troubleshooting and making it production ready and working more and more in production environments. His name is LAN. That strategy of hiring people who have a networking name, that totally has helped me here. So just a quick tip for you guys. And ISP specific. So we can see all of the networks involved, identify them. We can identify where the performance impact is and quantify it very precisely as it relates to the end-to-end performance. And we can do that at a broad scale now. We also have developed technology to be able to figure out which portion of the path is yours, where you may not have an autonomous system in your private network, but we can still discover that. So we've got a really broad data set on where people's network problems are happening. So we've got some really interesting thoughts about ISP-specific data. I want to talk to you more about that later, but I can't share any of that yet. Facebook, I went to Nanog 66. Have any of you guys been to Nanog? It's a fantastic conference, very, very technical, very much like the people that run the biggest networks in North America have their most technical people come and present on what are the challenges they're having today and how are they solving them. So really cool talk. You see people like Facebook, Netflix, a bunch of carriers, so carrier network CDNs and other really big networks. We learned that Facebook is also really monitoring their paths. They have a very different use case because they don't have to discover the path, but they intentionally monitor each separate path and then do it at a very fast rate, down to seconds, and I think their intervals minutes, and they generate gigabits of traffic just through monitoring every path. So really cool, and there's a link there if you want to watch that session. I thought it was really interesting. Some customer anecdotes. One of the cool things is hearing, like, after you deploy a tool, what are people saying about it, or what do they think, what surprises them. And one of the coolest things we often hear is, I did not know that's how I was sending that traffic. I didn't know that device was even involved in that path. Another cool thing we've heard is this guy, one of our customers, was having a problem with his path, and he identified the problem in his provider's network. He called the provider and said, hey, you have router X and router Y, and I'm experiencing this amount of delay, or this amount of introduced delay, or packet loss is sort of bad behavior, and here's the interfaces involved, and could you fix that, please? And their first question was, how do you know that? Can you send us a screenshot of this tool that you're using? So that's kind of exciting for us. And the intent here is to point fingers intelligently, right? Like, we don't want to go around and blame everyone, but we absolutely don't want to work on problems that are not our problems. And we want to, for whomever's problem that is, we want to provide really precise and actionable information for them to go and solve that. We can take a look at some specific examples from one of our customers, Christopher Good. So thank him. I thank him very much for providing these examples. He works at RFK Solutions. This is Netpath running in their environment. He says they found a virtual machine queue issue on their host server NIC. That's not something we were intending to go and find. Like, it just amazed me that he found that. And he found that because the problem was literally his transit from his endpoint to their first hop. That's where he found the problem. Another example is he found a specific problem over in GoDaddy's network. For them, he was mentioning how we know exactly who to blame. He did use the word blame. And we know exactly where their problem is, which is great. That's the goal. And reminder that we're checking the whole path. So when we put in www.solarwinds.com, if DNS resolution fails, customer can't reach it. So we're going to report that as a DNS error. And then you'll have, of course, the old path and the time when that occurred.